Hello all. So in the last session we have seen what is attention mechanism, how does it overcome the disadvantage of sequence to sequence model, right? So today in this session we will discuss about how do we implement that attention mechanism into the sequence to sequence model architecture. Okay, so we've seen that attention mechanism is basically used for creating the summary of the input under specific context. Instead of generating one fixed vector representation of the input sentence, we try to split the given input sentence into key value pairs and then try to generate a context dependent summary using attention mechanism, right? So we used a key value store and then we compared that with a query to generate attention weights and all that, right? So the figure here actually illustrates how do we implement this attention mechanism into the sequence to sequence model. The earlier sequence to sequence model consists only of the basic encoder model and the decoder model. But as you can see here, the encoder model, we've attached some extra components to the encoder model because I don't want to generate the fixed vector representation, but I want context dependent summary. So as you can see here in the figure, this example is all about language translation. Okay, so I'm trying to translate these words Maria, no, Baba, Verde into some other language. Okay, so what we do is we give these tokens as inputs to the basic RNN architecture, right? And then on top of that, the output of this RNN, as you can see, is given to the key value pairs. That is, each token in the source language would be processed by the key value pair, where that key value pair would be compared to the query. As I told you, the query is like the predicted output, sample reference output. So the key value pairs are compared with the query with respect to these attention functions, and the weights are calculated. Attention weights are calculated, which are then given to the softmax function for calculation. So once from this attention mechanism, we will be getting the weighted sum of all the tokens. Now this weighted sum will generate the context dependent summary here, which will be given as input to the decoder block. Okay, I am not making any changes in the decoder block. As you can see, the only change that we have made is onto the encoder block, where we have attached the attention mechanism blocks. Okay, so it is just a RNN based, basically it is just an RNN based sequence to sequence model with some extra things added on the top of the encoder. Okay, so if you ignore what's inside and see it is a black box, all it does is simply take query and return some sort of summary created from the input. Okay, so there are 3 points that I would like to explain when we talk about using attention mechanism to the sequence model. The first one is the input to the attention mechanism is nothing but the list of hidden states computed by the encoder, that is the RNN block. Okay, now these hidden states are used as both keys and values. Okay, remember the keys and the values should be identical. Okay, now the encoder hidden state a particular token, for example Maria, no, Baba, Verde. Okay, let's example take a token called no. This token reflects the information about the token and all the other tokens that are leading up to the entire sentence. That is, you can go for either unidirectional if it is leading up to, or if you want the entire sentence, you can go for bidirectional model. Okay, now let's say you have finished decoding up to Mary did. Okay, so I have 4 words here: Mary, Maria, no, Baba, Verde. Okay, the output here is Mary did not. Okay, so let's say we have completed till Mary did. Okay, the hidden states of the decoder at this particular point are used as query, which is compared against every key using function f. Now this produces a list of attention scores, 1 per each key value pair, and these scores actually will determine which part of the input the decoder should attend to when it's trying to generate a word that follows Mary did. After Mary did, what is that word I have to think about to generate? Okay, once it does that, these scores are all converted into probability distribution. That is the reason I am using a softmax function there, which is used to determine which vectors will actually get the most attention. Okay, Once we are done with this, the written value from this attention mechanism is nothing but the summed weights, weighted sum, or the sum of all values weighted by the attention scores after normalizing the softmax function. Okay. Now, as I told you, we may be wondering what the attention function f look like. What exactly is this attention function? Okay. So there are many variants available, couple of variants which we have used here in the context. Depending on how it computes the attention codes because of the key and the query, these details does not much value here. Don't worry about what kind of attention f we use. Okay. But one important thing, there is a good paper called, you know, there is a good paper on attention evaluation 2017, and while proposing this attention mechanism, the authors actually referred to using a mini neural network for generating these, attention scores from the key value pairs. They have used this word called as mini neural network. Okay, now let's see what exactly is this mini neural network. Okay, now when I talk about attention function, this mini network based attention function is something you just plug into an RNN model post hoc and expect it to work. As simple as that. Okay, basically it is optimized as part of the entire network. That is, the entire network gets optimized because we need optimization here, normalization, because the entire loss function should be calculated and should be minimized, right? So the entire network gets optimized by minimizing that particular loss function, with which the attention mechanism also gets better at generating those summaries. We generate those summaries and then we add them, right? We add them, we weight the summary, and then finally try to generate the context dependent summary. So this attention mechanism gets better when you summarize while generating the tokens. And also, not just about the encoder, it will also help the decoder generate better translation and lower the loss function. Okay, so that f function we use is basically a mini network based attention function. In other words, attention is nothing but calculating some sort of, soft word alignment between the source and target tokens, which is taken care by this particular attention function, as you can see here in the figure here. Okay, so this function is actually mainly used for calculating the attention weights depending upon the query and the key value pairs, and that attention weights with respect to probability calculation using softmax function are used for calculating the weighted sums, with which we will be able to generate the context dependent summary, which will be given to the decoder as inputs. So basically, in order to reduce the loss function, we will be using this mini network based attention functions. Okay, so this is all about how do we implement attention function into our sequence to sequence models. Thank you so much.